Hello everyone, I am Amit Maru and today in this video we will discuss about how to solve 8 queen problem. In this video we will discuss step by step different two examples of 8 queen problem and we will solve by using backtracking concept. So let us start our today's video on how to solve 8 queen problem. In this video we will discuss two different examples so that you can easily understand how to solve 8 queen problem. So let us discuss our first example. Solve 8 queens problem for feasible sequence 6, 4, 7 and 1. Here position of first 4 queens are given and we have to identify position of remaining 4 queens. As we discussed in our previous video, we will place our queens row wise. So first queen will be placed on first row, second queen will be placed on second row, third queen will be placed on third row and so on. And the value indicates column number. For example, 6 indicates column number 6, 4 indicates column number 4, 7 column number 7 and column number 1. So if you want to read this line, then we can read that our first queen is available on first row 6 column. So first row 6 column. Second queen is on second row 4th column. Second row 4th column. Third queen is on third row 7th column. So this is third row and 7th column. And our fourth queen is available on 4th row 1st column. So this is the 4th row and 1st column. So this feasible sequence is given and we have to identify position of remaining 4 queens. So we have to identify the position of 5th queen, 6th queen, 7th queen and 8th queen. As we discussed, we will place our 5th queen on 5th row, 6th queen on 6th row, 7th queen on 7th row and 8th queen on 8th row. So there is no clash of row. So same 2 queen will not be on same row. So let us solve this example by using backtracking concept. So feasible sequence already given for the 4 queens, that is 6, 4, 7 and 1. So first queen is available on first row 6th column, second queen is on second row 4th column, third queen is on third row 7th column and fourth queen is on 4th row 1st column. And we have to identify the position of remaining 4 queens. As we discussed, we are placing our queen row wise. So our 5th queen will be placed on 5th row, 6th queen will be on 6th row and the 7th queen on 7th row and 8th queen is on 8th row. So there is no chance that the 2 queens will be on same row because we are filling row wise over all the queens. So there is no chance that the 2 queens will be on same row. Now second thing is, as we discussed, this value indicates column number. So 1 queen is available on column number 1, 1 queen is available on column number 7, 1 queen is available on column number 4 and 1 on column number 6. So we are not using or we are not repeating this value. Otherwise it will be on same column or 2 queen will be on same column. So once we are not repeating this value, at that time there is no chance that 2 queen will be on same column. So as per our constraint, the 2 queen must not be on same row, must not be on same column. So now there is no chance that the 2 queen will be on same column or same row once we place our queen row wise or once we are not going to repeat this value. Now we have to check third condition, which is important. Our 2 queen must not be on same diagonal. That we cannot directly judge or directly we can check. So that we have one equation. So you just remember this equation. For example, we have a 2 position of 2 queen. Position number 1 is ith row and jth column. Position number 2 for the queen number 2 is kth row and lth column. Now the 2 queens are on same diagonal if the row plus column of first queen is equal to the row plus column of second queen. If we perform addition between row and column of first queen and addition of row and column of second queen, if the value is both are equal, it means that both queens will be on same diagonal. Same way, if I minus j, or we can say the row of first queen minus column of first queen is equal to the row of first queen minus column of row of second queen minus column of second queen, at that time these two queen will be on same diagonal. So every time we need to check this condition before placing this queen on our chessboard. So just take one example. Suppose our first queen is available on second row third column, so I is equal to 2 and j is equal to 3, and our second queen is available on fourth row first column. For example, here the value of k is equal to 4 and l is equal to 1, or we can say the value of row is equal to 4 and column is equal to 1. So once we perform addition between row and column of both the queen, then we can say the first queen has addition of row and column 2 plus 3 is equal to 5, and here the addition of row and column 4 plus 1 is equal to 5. It means that both are equal, so that it will be on same diagonal. Just check that it is on same diagonal, and this is not allowed, or we can say one queen will attack on another queen once it is on same diagonal. Right? Same way you can check I minus j is equal to k minus l. For example, one queen is available here and second queen is available here, then 1 minus 1 is equal to 0 and 2 minus 2 is equal to 0. So both are equal, then both the queens are on same diagonal. So before placing queen on chessboard, we need to check both the condition, row of first queen and column of first queen. Once we perform addition between this row and column of first queen and addition between row and column of second queen, it must not be same. If it is same, it means that both queens are on same diagonal. Same way need to check I minus j equal to k minus l, or subtraction of row and column of first queen. If it is equal to the subtraction of row and column of second queen, then both the queen will be on same diagonal. So every time we need to check before placing our queen on chessboard. So for example, this is the feasible sequence given, so we are not going to change this value. We have to just identify remaining position, or we can say the remaining position for remaining queens. So for example, if we find the position of queen number 5, so as we discussed, we will place on row number 5. So for example, if we place our queen on row number 5, then we need to identify on which column we need to place the queen number 5. So we cannot place on column number 1 because fourth queen is available on column number 1. Then we can place on column number 2 because 2 is not available in this list. So fifth row and second column. So we can place our queen here, but as we discussed, we need to check this condition. Both this queen must not be on same diagonal, and that we can check by using this equation. So once we check that 5 plus 2 is equal to 7. So we need to check that any queen out of these 4 has a addition of row and columns is equal to 7. If yes, then we cannot place our queen on column number 2. Just check 5 plus 2 is equal to 7. Here 6 plus 1 is equal to 7. It means that queen number 1 will clash with the queen number 5. If we place our queen number 5 on second column, then both the queen will be on same diagonal. So we cannot place queen on second column. So just check on third column. Our another option is if we place our queen number 5 on third column, then 5 plus 3 is equal to 8. So we need to check that any queen has the addition of row and column is equal to 8. Here 1 plus 6 is equal to 7, 2 plus 4 is equal to 6, 3 plus 7 is equal to 10, and 4 plus 1 is equal to 5. Another condition we need to check, 5 minus 3 is equal to 2. So 1 minus 6, no. 2 minus 4, minus 2, no. 3 minus 7, no. 4 minus 1 is equal to 3. So we can place our queen on fifth row, third column. Then there is no clash, or there is no clash between any queen of this 4. So we can place our queen number 5 on fifth row, third column. Now we need to place our queen number 6 on 6th row. So let us check. Now 3 is fixed, so that 3 as it is, and we have to place our 6th queen on column row number 6. So we need to check on which column we can place our queen number 6. We cannot place on column number 1, but we can place column number 2. So just check with the column number 2. 6 plus 2 is equal to 8. So we need to check addition of row and column of any queen. 6 plus 1 is equal to 7. 4 plus 2 6. 7 plus 3 10. 1 plus 4 5. 3 plus 5 is equal to 8. And here 6 plus 2 is equal to 8. So 5th queen and 6th queen will be on same diagonal. So we cannot place our 6th queen on 6th row, 2nd column. So we need to check another possibility. Now we cannot place on first column, we cannot place on 2nd column, we cannot place on 3rd column, we cannot place on a 4th column. So only one possibility here is we can place on 5th column. So let us check with the 5th column. Here 6 plus 5 is equal to 11. Then 1 plus 6 is equal to 7. 2 plus 4 6, 3 plus 7 10, 4 plus 1 5, 5 plus 3 8, and here 6 plus 5 is equal to 11. So no queen are on same diagonal. We can check another possibility, that is 6 minus 5 is equal to 1. So is there any queen which has a subtraction of row and column is equal to 1? 1 minus 6 is equal to minus 5, so no. 2 minus 4 minus 2, 3 minus 7 minus 4, 4 minus 1, 3. So that we can say that one thing is, again we need to check here, 5 minus 3 is equal to 2. So no queens are on same diagonal, so that we can place our 6th queen on 5th column. Same way, let us place our 7th queen on 7th row. So we need to check on which column we can place. Here 1 already occupied, 2 is not occupied, so that we can place our 7th queen on 7th row, 2nd column. Again check, 7 plus 2 is equal to 9. So is there any queen has a addition of row and columns is equal to 9? Just check here. No queen has a addition of row and column is equal to 9. Another condition, 7 minus 2 is equal to 5. Is there any queen out of this 6th queen which has a column minus row minus column is equal to 5? Just check. So no queen has a row minus column is equal to 5. So that it means that we can place our 7th queen on 7th row, 2nd column. Now last queen we need to place on chessboard, that is 8th queen. So we cannot place on 1st column because 1st column is occupied, 2nd column is occupied, 3rd column, 4th column, 5th, 6th and 7th column occupied. So we have only one possibility, that is 8. So we need to place our queen on 8th row, 8th column. Just check here, 8 plus 8 is equal to 16. So we need to check that is there any queen which has an addition of row and column is equal to 16. Here 7, 2 plus 6, 4 plus 2 6, 6 plus 7 10, 4 plus 1 5, 5 plus 3 8, 6 plus 5 11, 7 plus 2 9. Same way we need to check 8 minus 8 is equal to 0. Any queen which has a subtraction of row and column is equal to 0? No. For 2nd queen, no. For 3rd queen, no. 4th queen, no. 5th queen, 5 minus 3, so no. 6 minus 5, no. 7 minus 2 is equal to 5. So no queens are on same diagonal. So this is the correct position. So the remaining queen will be on 5th row 3rd column, 6th row 5th column, 7th row 2nd column and 8th row 8th column. Then there is no queens are on same row, same column and same diagonal, and this is our correct solution. So finally we can say that once we place this all the queens, then this will be first position of 4th queen, first 4 queens are already given, and we have identified position of 5th queen, 6th queen, 7th queen and 8th queen. Just check here, no queen will be on same row, same column and same diagonal. So this is the answer. Once we observe this example, then in this example there is no use of backtracking, because we have not go back and we have not identified another path. But let us take another example where backtracking is compulsory. So another example, for example, for feasible sequence 7 5 3 1, so solve 8 queen problem by using backtracking concept. Here the feasible sequence of 4 queens given. For example, first queen is available on first row 7th column, second queen is on second row 5th column, third queen is on third row 3rd column, and fourth queen is on 4th row 1st column. And we have to identify the position of remaining 4 queens. Here we need to fill the value. So let us use same example, let us use same concept to solve this problem. So we have 4 different queens with a feasible sequence, that is 7 5 3 and 1. As we discussed, there is no chance that 2 queens will be on same row, because we are placing our queen row by row, and there is no chance of 2 queens which will be on same column, because we are not going to repeat this value, and this value indicates column. But we need to check every time the two queens must not be on same diagonal, and that we can check by using this 2 condition. So let us find the solution, or let us find the position of remaining 4 queens. For example, if we place our 5th queen on 5th row, and we need to identify the column number. We have already occupied the first column, so we can use another column, that is our 2. So we can check with the column number 2. If we place our queen number 5 on 5th row 2nd column, then we need to check that there must not be a in same diagonal with any remaining 4 queens. So we need to check that 5 plus 2 is equal to 7. So is there any queen out of these 4 which has a addition of row and column is equal to 7? So we need to check that 7 plus 1 is equal to 8, 5 plus 2 is equal to 7. Here 5 plus here 2 plus 5 is equal to 7, and here 5 plus 2 is equal to 7. It means that our queen number 5, which is available on 5th row 2nd column, will have a same diagonal with our second queen, because it is available on 2nd row 5th column. So we cannot place our 5th queen on 5th row 2nd column. Now can we place on our 3rd column? We cannot place, because 3rd column already occupied. So we can place our 5th queen on our 5th row 4th column. Just check with the 4. Now perform addition. 5 plus 4 is equal to 9. So any queen which has the addition of row and column is equal to 9. 7 plus 1 8, 5 plus 2 7, 3 plus 3 6, 1 plus 4 is equal to 5. So this queen will not be on same diagonal, but we need to check another condition, that is 5 minus 4 is equal to 1. So once we perform subtraction of row and columns, at that time our value is 5 minus 4 is equal to 1. So we need to check with remaining all the queens. 1 minus 7, so minus 6, 2 minus 5, minus 3, 3 minus 3 0, 4 minus 1 3. So this position is correct position. This queen, once we place our 5th queen on 5th row 4th column, at that time it will not be on same diagonal with this all the 4 queens. Now we need to place our 6th queen. As we discussed, this 6th queen will be placed on 6th row. So now this is correct solution, so that we need to put 4 directly, and we have to identify the position of our 6th row, or we can say 6th column. So place our 6th queen on our 6th row. So once we place on our 2nd column, because on 1st column we cannot place because 1 is already available, so we can check with the 2. Can we place our 6th queen on 6th row 2nd column? So we need to check this condition. 6 plus 2 is equal to 8. Here 1 plus 7 is equal to 8. It means that it will be on same diagonal with our queen number 1. So we cannot place our queen 6th queen on 6th row 2nd column. We need to check another possibility. So 4 as it is, because it is correct solution, and we need to change this value. We can change another value. In place of 2 we can use, for example, 3. No, we cannot use 3 because 3 already occupied. 4 already occupied, 5 is already occupied, so we can place our 6th queen on 6th row, 6th column. Now check this diagonal, whether it is on same diagonal or not. So 6 plus 6 is equal to 12. We need to check addition of row and column of this 4 queen. 1 plus 7 8, 2 plus 5 7, 3 plus 3 6, and 4 plus 1 5. Another condition, 6 minus 6 0. Here 3 minus 3 is equal to 0. It means that it will be on same diagonal. So our 6th queen will be on same diagonal of our 3rd queen. So this position is not correct. We need to change this position. We have to change this column. So in place of 6, we need to check whether we can place on column number 7. No, because the 7 already occupied. So only one possibility, that is our 8. So 4 as it is, and we can place our 6th queen on 6th row, 8th column. Now we need to check whether it is on same diagonal with this all the queens or not. So 6 plus 8 is equal to 14. So we need to check addition of this all the columns. So no queen has a addition of row and column is equal to 14. Then 6 minus 8 is equal to minus 2. We need to check that no queen has a subtraction of an row column is equal to minus 2. It means that this is correct position of our 6th queen, which is now available on 6th row, 8th column. Now we have to identify the position of our 7th queen. So this both are the fixed. So 4 and 8 both are fixed. We have to identify position of our 7th queen, and definitely we will place on 7th row, and we have to identify on which column we can place. So now on first column we cannot place our 7th queen because first column is already occupied. So we can start with the 2. If we place our 7th queen on 7th row, 2nd column, again we need to check diagonal. So addition of 7 plus 2 is equal to 9. So we need to check any queen which has an addition of row and column is equal to 9 or not. So here just see our 5th queen is placed on 5th row, 4th column. So that 5 plus 4 is equal to 9, and here 7 plus 2 is equal to 9. It means that it will be on same diagonal, so that we cannot place our 7th queen on 7th row, 2nd column. So let us change this column. So can we place on a 3rd column? No, because 3rd column is already occupied. Can we place on 4th column? No, 4th column is already occupied. Same way 5th column is also occupied. So we can place on 6th column, 7th row, 6th column. So remaining value as it is. So 4 and 8 both are as it is, and we can place our 7th queen on 7th row, 6th column. Once we place on 7th row, 6th column, at that time we need to check whether it is on same diagonal with this all the queens. So perform addition. 7 plus 6 is equal to 13. Is there any queen which has addition of row and column is equal to 13? Just check. 7 plus 1 8, 5 plus 2 7, 3 plus 3 6, 1 plus 4 5, and 5 plus 4 9, and 6 plus 8 is equal to 14. Now we need to check the subtraction. 7 minus 6 is equal to 1. So is there any queen which has a subtraction of row and column is equal to 1? Yes. 5th queen has 5 minus 4 is equal to 1. So 5th queen is on 5th row, 4th column. So 5 minus 4 is equal to 1, and 7 minus 6 is equal to 1. It means that this both the queen, 5th queen and 7th queen, will be on same diagonal. So we cannot place on column number 6. So we need to check another possibility. Can we place on column number 7? No, because 7 already occupied. Can we place on column number 8? No, because our 8th column is also occupied. So now there is no chance that we can place our 7th queen on chessboard. So that now we need to use a backtracking concept. As per the backtracking concept, we need to just go back and find the another solution, or we need to go back and reposition the previous queen. So our previous queen is our 6th queen, which is available on 6th row, 8th column. So can we reposition the location of our 6th queen? No, there is no chance, because our 6th queen is available on last column, that is our 8th column. So there is no chance where we can reposition the queen number 6. So we need to again go back and we need to reposition our previous queen, that is queen number 5. Can we reposition the queen number 5? our queen number 5 is available on 5th row, 4th column. So now there is a chance where we can reposition our queen number 5. So let us reposition, or let us change the column of our 5th queen. Now 5th queen is available on 5th row, 4th column. So can we place on 5th column? No, because 5th column is already occupied. Can we place on 6th column? Yes, we can place on 6th column. So let us check whether it is on same diagonal with previous any queen. Here 5 plus 6 is equal to 11. So there is no any queen here which has a addition of row and column is equal to 11. Same way we need to check subtraction. 5 minus 6 is equal to minus 1. So there is no any queen which has a subtraction of an row column is equal to minus 1. It means that 6 is correct answer. Here we can place our queen number 5. So our queen number 5 is now available on 5th row, 6th column. Now we need to identify the position of our 6th queen. Now when we identify the position of our 6th queen, we need to check on which column we can place our 6th queen, because it will be on our 6th row, and on which column we can place. On we cannot place on our first column because first already occupied. So we can check with the second column. Once we place on a second column, then just check whether it is on same diagonal with this all 5 queens or not. So 6 plus 2 is equal to 8. So is there any queen out of these 5 which has addition of an row and column is equal to 8? So here the first queen 1 plus 7 is equal to 8, and 6 plus 2 is equal to 8. It means that it will be on same diagonal with our queen number 1. So we cannot place our queen number 6 on column number 2. So now we need to change the column. So can we place on our column number 3? No, column number 3 already occupied, so we can use column number 4. So this is fixed. Now we can place our 6th queen on column number 4. Now again we need to check 6 plus 4 is equal to 10. So is there any out of this 5 queen, is there any queen which has addition of an row column is equal to 10? No. We need to check 6 minus 4 is equal to 2. So is there any queen out of this 5 queens which has a subtraction of row and column is equal to 2? So no any queen which has a subtraction of row and column is equal to 2. It means that this is our correct position. We can place our 6th queen on 6th row, 4th column. Now we need to identify the position of our 7th queen. So these both are the fixed, and we need to identify the position of our 7th queen. So let us check on which column we can place our queen number 7. Can we place on column number 1? No, because 1 is already occupied. We can place on column number 2. So let us check with the column number 2. Let us check a diagonal. 7 plus 2 is equal to 9. So is there any queen out of this 6th queen which has addition of row and column is equal to 9? So no queen has addition of row and column is equal to 9. Same way need to check 7 minus 2 is equal to 5. So no queen out of this 6 queens which has a subtraction of row and column is equal to 5. It means that this is the correct position of our queen number 7, and that is our 7th row, 2nd column. Now we need to place our last queen on 8th row. So once we place on 8th row, we need to identify the column. So we already occupied our column number 1, column number 2, column number 3, 4, 5, 6 and 7. So only one chance, that is we can place our 8th queen on 8th column. So this is fixed, and here we can place suppose our 8th queen on 8th row, 8th column. So just check whether it is on same diagonal with remaining 7 queens. So 8 plus 8 is equal to 16, but no queen has addition of an row and column is equal to 16. Another condition, 8 minus 8 is equal to 0. So here the 3rd queen is on 3rd row, 3rd column. So 3 minus 3 is equal to 0, and here 8 minus 8 is equal to 0. So it will be on same diagonal. So we cannot place our 8th queen on 8th column. Now there is no any option where we can place our 8th queen. So that we have to again use backtracking concept. We need to go back. We need to reposition our 7th queen. Can we reposition our 7th queen? Yes or no, that we need to check. but there is no chance to reposition our 7th queen because our 7th queen is available on 7th row 2nd column. So once we change the column, for example on 3rd column, then 3rd column already occupied, 4th column already occupied, 5th column already occupied, 6th column already occupied, 7 also occupied. So we have only one chance that we can place on 8th column. But once we place on 8th column, at that time 7 minus 8 is equal to minus 1, and here 5 minus 6 is equal to minus 1. So it will be on same diagonal with our 5th queen. So there is no chance where we can reposition our queen number 7. Now we need to again go back and we need to reposition our queen number 6. Once we change the location of our queen number 6, then we need to check any other column where we can place our queen number 6. So we already placed on column number 4, so we need to check whether we can place on column number 5. No, because 5 is already occupied, 6 already occupied, 7 already occupied, so we can place on column number 8. So once we place on column number 8, at that time we need to check whether it is on same diagonal with any queen or not. So 6 plus 8 is equal to 14. So there is no any queen out of this 5 queen which has addition of row and column is equal to 14. We need to check another condition. 6 minus 8 is equal to minus 2. So out of this 5, no queen has a subtraction of row and column is equal to minus 2. It means that this is the correct position for our queen number 6. So we can place our queen number 6 on 6th row 8th column. Now find out the position of our 7th queen. So this is the fix. 6 and 8 both are fixed. So we need to identify the column for the queen number 7. Can we place our queen number 7 on 1st column? No, because 1st column is already occupied. Can we place on 2nd column? Yes, we can check with the column number 2. Once we place on column number 2, at that time we need to check whether it is on same diagonal with this all 6 queens. So 7 plus 2 is equal to 9. So out of these 6 queens, there is no any queen which has the addition of row and column is equal to 9. We need to check another condition. 7 minus 2 is equal to 5. So out of this 6 queen, there is no any queen which has a subtraction of row and column is equal to 5. It means that this is the correct position of our 7th queen. We can place our 7th queen on 7th row 2nd column. Now last queen, that is our 8th queen. So this is the fix. 6, 8 and 2, these all are the fix, and we need to place our last queen, and we need to identify on which column we can place our last queen. So can we place on column number 1? No, 1 is already occupied, 2 is already occupied, 3 already occupied, 4 is not occupied, so we can place on 4. So we are now trying to place our 8th queen on 8th row 4th column. So we need to check whether it is on same diagonal with this all 7 queens or not. So 8 plus 4 is equal to 12. So there is no any queen which has a addition of an row and column is equal to 12. Second condition, 8 minus 4 is equal to 4. So just check, there is no any queen out of these 7 queens which has a subtraction of row and column is equal to 4. It means that we can place our 8th queen on 4th column. So this is the correct solution. Now we can place our remaining 4 queens on 6, 8, 2 and 4. So this is our correct solution, and our solution says that once we place our 5th queen on 6th column, 6th queen on 8th column, 7th queen on 2nd column and 8th queen on 4th column, at that time we can have a correct solution. So in this way we can use backtracking concept to find the solution of our 8 queen problem. So thank you very much for watching this video.